Today's webinar, I'll start with introduction to the field. That is, I'll talk about the basic definition of infrared cameras. What are the basic uh, ideology that you have to understand before moving on to the advanced topics in this. Then I'll talk about the functionalities of infrared cameras, how they work, what's basically inside the camera. And once we know the basic definition and functionality, then I'll move to application in autonomous industries, how we can use infrared cameras instead of normal cameras. And whenever I say normal cameras, please try to understand that I'm talking about the daily RGB camera that we use. So it's not some fancy term. So please make sure you understand the term. Once we know the application in autonomous industry, then I'll move to advantages and disadvantages. Like and then once we have this, I'll move to career path. What could be the possible career path in this field? And at the end, we'll have a demo video. First, I'll start with introduction. So on the right, you can see an image. So it's just not to show on the screen. You can see the different range of different sensors. Last on the right, top bottom, you can see the thermal imaging. This is the range of IR sensor. So thermal sensor or IR sensor is one of the same thing, so please don't get confused.
I'll start again with the infrared cameras. So infrared cameras are nothing but just non-contact device that detects infrared energy, that is heat. All the bodies, all the objects contain heat signatures. The basic job of infrared camera is to capture the heat and then quantify it on a scale of temperature. On the right, we can see the temperature scale of an image here. 18 being the coldest and 32 being the hottest in this case. So what IR camera do is it converts the energy into an electronic signal, and then there's a post-processing inside the camera that converts this electronic signal to produce a thermal image. So on the right, what you're seeing is a thermal image. And as we can see, the heat sensed by an IR camera can easily be quantified in terms of temperature. So it is quite important for us to have this quantification because in order to recognize or classify the object in an image, it is important for the user to understand the temperature differences. Now, what is an infrared spectrum? So this is all high school physics that we all have studied. So infrared spectrum is just next to our visible spectrum, the visual spectrum that we see daily, the VIBGYOR, and it has wavelength of around 750 to 1400 Newton nanometers, which is much longer than what we see in our daily lives, that is 380 to 750 nanometers. So IR cameras sense this IR spectrum, and it can capture the wavelength much higher than the visual spectrum. So it makes it quite handy for the researchers and for the engineers to use it in the autonomous industry because it can capture higher wavelengths rather than just a smaller range that a visible camera can detect. So once we have the infrared spectrum, then we classify it into three different types: near infrared, mid infrared, and far infrared. So this classification is based on the distance from the color red. So as you've seen in the image before, the image with the VIBGYOR, so red comes the last in the wavelength. It has the highest wavelength. So we calculate the distance from the red color. So based on the distance from the red color, we classify it into near, mid, and far. And based on the usage, we can use the different type of IR sensors. Now the first question come, how do IR cameras work? So if anyone wants to type in the chat the answers to this, I'll mention them later. So please, I'll try to keep it as interactive as possible. So keep writing in the chat box. So what is inside the camera? A normal camera is consists of a mechanical housing, a lens, and a processing unit. It's not much complex. It's just we have a different sensor inside the camera. That is a thermal sensor, and the rest of the units are same, just as like the normal visible camera. So as soon as we have heat signature from a particular body, the lens focus that energy onto the sensor. And then, as I've mentioned in the first slide, the sensor converts it into an electronic signal, and then later it produces a thermal image. Regarding configuration, we have different configurations here, starting from 80 into 60 to 180 into 1024. So we had different configurations available in the market. So if you're working in this field, if you're a researcher, then you have to select the particular configuration for the particular usage. But before we select a particular IR camera, we need to consider specific specifications. That is, first is resolution that I have just discussed in the above point. That is the quality of the image that is being produced on the camera. So it is quite important for the user to see if the image that is being generated from the camera is good or not for the usage. And once we have resolution, then we move on to field of view. A field of view of a camera is nothing but the area that the lens can see when in use. So FOV plays a very important role in autonomous vehicles because FOV defines how much your car can see, how much the vehicle can see. So it is very important for us to consider the FOV when selecting the infrared camera. And then comes the sensitivity. Sensitivity is nothing but just a change the camera can, measure the change in temperature the camera can measure. So it is basic sensitivity. And the spectral range is the span of temperature that camera is calibrated to and is able to detect. So in these important specifications, personally, I feel field of view and spectral range is very important if you're selecting a particular infrared camera because these two define the daily usage. So now we move on to what are IR cameras able to detect. So on the right, you can see an image of wild animals that is here. And you can see here that even with the cluttered background, the camera can detect different objects here. All the objects have kind of same heat signatures, but still it is able to classify between them, which is one of the biggest advantage of IR camera. So as we know, as I've told you earlier, every object has a heat signature. Even ice has a thermal energy that gives out. And human eye and normal camera works on the same concept. That is, we capture the image based on the visible light. So what we see is a light. The light is reflected from a particular object, and then our eye or the normal camera captures the image. But the IR camera does not work on this same concept. It captures the thermal energy emitted from an object, and that is what is called heat signature that I have already told you about. What are the main things that IR camera is able to detect is it can detect even tiny differences in heat that is as small as 0.01 degrees Celsius, which is a big thing because in a cluttered background or in a crowded space, it is really important for the classification that camera can detect each and every person or each and every animal. So this is the big advantage of it. And higher the object's temperature, the greater the IR radiation emitted. This is very basic and this is very common. So by now we should know that I've told you every object emits heat. So higher the object's temperature, the greater the radiation emitted. For example, if we see the image of a car, we can clearly identify that the temperature of the engine is much higher than the temperature of the as I've shown you the image, the different temperatures are displayed via different colors. So we move to next slide. Why autonomous vehicles need IR cameras? Again, I want you guys to please type in the chat box and answer why do you really think we need IR cameras when we already have normal visible cameras. So on right, this is an image of object detection using thermal cameras. So before understanding why autonomous vehicle need IR cameras, we first need to know what are the limitations of normal camera. So on right, you see this image on and in the image on left, we have a normal camera image. On right, we have thermal camera. As I've already discussed, visible cameras depend on light, and whereas IR cameras depends on the heat signatures emitted from the bodies. But the main problem of normal camera is it cannot operate in severe weather conditions. For example, if you have a foggy night, if you have a foggy day, if you have a dark night, if it's heavy snow, then normal camera cannot operate in those conditions, and we need a thermal camera in order to see beyond a certain limit. Also, at night, when we test the vehicle on a highway, we have light pollution because of the vehicles incoming from the opposite side. So in that case, it creates a blind spot of the camera. And when I say blind spot means the specific condition in which a camera cannot see and it cannot signify or classify what object is there. So it is really important for the researchers to consider this scenario when deciding about the camera. And so in the last point, you can see visual camera sometimes miss a pedestrian obstructed by a lamp or tree. That is also one of the biggest disadvantage. So the problem is if you're standing uh, near the road and if you're standing beside a tree, so normal camera won't be able to see the pedestrian. And if a pedestrian tries to cross the road, there will be a severe accident. So when I talk about accident, these are the current concerns right now that researchers are trying to deal with. One of the problem is the road accidents. I guess all the autonomous driving aspirants has studied about this thing that accident happened in Arizona. So the problem that happened was the autonomous car, which was in the testing mode, hit the pedestrian on the road. So the main problem we have right now, the main concern we have right now is pedestrian and animals are not detected due to bad lighting conditions. So on right in the image, you can see that we have two accidents here. So 1, 2, 3, 4, 5 are the different levels of autonomous vehicles, which is defined by SAE. And in first level, we have driver assistance. That is, driver is able to make the decisions most of the time, and the car's operating system doesn't do much. In the second level of automation, that is partial. In this, the driver and the operating system of the car work in coordination. And while testing level 2, Tesla hits the cop car while illegally on autopilot. So this was again a breaking news in 2018. It is conditional that the driver has to decide if it wants to interfere in the driving or not. Level 4 and level 5 are the full autonomous levels. So currently Tesla, Waymo, Lyft, Uber are all trying to test their vehicles for level 4 and level 5. And Waymo has already said that we are testing our vehicles on level 5. So these are the current concerns that these companies have to keep in mind. Here I'll show you a video of the Uber dash cam that I've shown you here, the self-driving car Uber accident involved. First, I'll show you the video, what happened there. So this was the scenario here. So I'll play it again and I'll let you know, guys, understand what happened here. So as you can see, when pedestrian was trying to cross the road in dark, the camera was not able to detect the pedestrian because it cannot see beyond the scope of headlights. But if we have thermal cameras in these scenarios, then it can easily detect the pedestrian's heat and can signify that okay, we have an object on the road and we need to brake or we need to steer a little. Usage of IR cameras, as I've already mentioned, that normal cameras are not able to operate in severe weather conditions or in during dark nights. And we have just seen an example how a pedestrian was hit by a car on the testing mode. So it is really, really important for the engineer, for the researchers to let car know the clear picture of the surrounding. Once we have clear picture of the surroundings, then the perception task is done, and then comes the controlling task, and which is later handled on. In harsh weather conditions, not all the sensors can operate. Now the one question come in mind: why not lidar? We cannot use lidar because it works on the same concept. It emits light and it traces back the light and detect the distance between the object and the vehicle, your autonomous vehicle. But there are certain conditions in which even LiDAR cannot operate. That is, if there are two cars running and if a person is crossing between those two cars, the LiDAR cannot detect the signal because the signals coming from these two vehicles obstruct the signal coming from the pedestrian. So there is one example, one scenario where LiDAR operation is not that good. And as I've already mentioned, since normal cameras cannot see beyond the scope of headlamps during nighttime driving, IR cameras are quite able to see beyond the camera headlight scope. On the right, you can see the image. On the left, we have an image from visible camera. On right, we have an image from IR's camera. So on the left, we can see the camera is not able to see if there is any pedestrian or any object present on the side of the road. But on the right, we can see that IR sensor can clearly identify there is an object on the side of the road, and it will ask the operating system that the control unit of the car to steer or to brake in this case. Also, the main usage of IR cameras is classification and detection. So when we come to autonomous vehicles, problem with LiDAR is, first of all, I'm not talking about cost here because that is one of the major issue of LiDAR. If you want, if you have this question, we can discuss it in the end because it's a very intensive topic and very subjective topic. But in terms of signal that I was discussing here, suppose you have two cars on the road and a pedestrian is trying to cross between those roads. So what LiDAR do is it emits the light rays and it captures the light rays, and based on the time measurement, it tells the distance, right? So it detects the object by capturing the signal from the object, right? So if you have a pedestrian crossing between those two vehicles, the signal generated from those two vehicles will obstruct the signal coming from the person. So I have practically worked on this case, and this is one of the biggest disadvantage of the LiDAR currently in the industry. And yeah, this is regarding the LiDAR. And FLIR cameras is nothing, just a company that is making IR sensors right now. It is the camera that is available. You can search it on the internet. You can read more about it. What is FLIR cameras? It's nothing but just a community company. And one question you might also have is, until now, we were only discussing about the temperature ranges in color scale. Nobody asked me why we are using grayscale here. So in order to get a clear classification, sometimes researchers switch to grayscale and they quantify the measure temperatures in a grayscale. This fog, uh, you get this fog picture, and on the right, the image generated from IR sensor, right? So instead of fog, if we have rain, it doesn't matter. It will not be obstructed because the person or any other object, it is already emitting heat. So thermal camera does not see the light waves or the object based on the light getting emitted from that. It is detecting object based on the heat signature. And as I've already mentioned, even ice has a particular heat signature, a particular heat value. So if it's snowing, if it's raining, doesn't matter. The camera will be able to detect the object. So normal sensors can operate easily in daylight, but there are also certain conditions. If we have a sun glare, it won't be able to operate normally, the normal camera. If we have a sunset mode on, and if we have a sun in front of the car, the camera won't be able to see on the road clearly, and it creates a blind spot. And in these particular conditions that I've talked about just now, sunrise or sunset condition, the IR sensor won't be affected by the sun glare or the sunset effect. It can easily detect the object on the road, the pedestrian or animal on the road. And in the end, in the demo video, you will see all these scenarios that I'm discussing right now, and I'm pretty sure it will be able to answer. Now, I was talking about the classification. Classification and detection is very, very important when we come to autonomous vehicles, because object detection is one of the major tasks of perception systems. So you can see on the bottom right, on the bottom, that we have an image from infrared cameras where it is quite able to detect the object, and 0.86, it is the confidence level that that your system has that it is a person. So if the confidence level is say 0.34 or zero point 0.2, then your system is not quite sure if it is an object, if it is a person or not. When we talk about object detection, the confidence score plays a critical role when deciding about a particular. And when I talk about class, we have different classes in object detection. It is pedestrian, animals, motorbikes, cars, trucks, etc. So there are around 80 classes right now in object detection algorithm, that is YOLO, currently in the market, leading the market. So yeah, we don't have to discuss about that. It's just for your information. I just talked about that pedestrians are especially at high risk after dark, and that we have seen in the Uber accident, that a pedestrian was trying to cross the road and it got hit by the car. So if it was the testing was done during daytime, they might have not gone through this. But since it was the testing was in the dark, they didn't consider this scenario. So there was an accident. So I already answered this question, that IR cameras are not affected by sun glare or darkness or fog conditions. Interesting question one of you has asked. I'm quite impressed that you've already moved to the advantages and disadvantages. So first, we talk about advantages. As I've mentioned in the previous slide, classification and detection task is quite important for autonomous vehicles, because classification and detection, I'll explain in brief. The perception system has to classify in an image in an environment if there is an object present on that scene or not. When I talk about image, we always talk in the image frame. That is, I talk about the pixel values. So the camera always work in pixel frame, not in the world frame. There's a big difference between camera and LiDAR. So if you have any kind of question with the frame system, that is the difference between image frame or the LiDAR frame or the vehicle frame, please feel free to ask questions in the end. So yes, as I was discussing classification and detection, so an object detection algorithm has to clearly classify if there is an object present in the scene. And once it is classified, now it has to tell the class of the object. On the right, you can see the image for different classes. That is vehicle, cyclist, pedestrian, and animal. That is dog. So why do we have different three classes for pedestrian here? It is a very interesting question, because before testing the cars in the real world environment, all the companies are testing it on the simulation. And one of the major issues that we have in simulation right now is the different shapes and size of human being. So they create these different sizes and they test the algorithm, the module on these different images, and they hope that it works in real time. The second advantage we have of IR camera is the detection done in the cluttered background. I hope you remember the image you saw with the deers in the beginning. In that, even with the cluttered background and so many animals present in the same place, the camera was quite able to detect them individually, even with the cluttered background. So this is one of the biggest advantage of IR camera. And also, I've told you the limitation about normal camera, that it is not able to identify an object or pedestrian that is being occluded by the tree or lamp. But in case of IR cameras, it can easily detect partially or fully occluded objects. Doesn't matter if the person is standing behind the building or behind the tree or behind a wall. The IR camera can easily detect it and can classify the object in an image. So now the big question comes the cost factor. IR sensors are quite costly when it comes to purchasing them, but the total maintenance cost or the total cost of ownership is quite low by then, because the maintenance cost of IR sensors is not high as compared to LiDARs, which are very expensive and can cost more than $100,000 for a company to purchase them. And as we have seen, it can easily detect human activities. So these are the advantages of IR sensors. Now we move to disadvantages and limitations. Biggest disadvantages that researchers are trying to deal with right now is the glare that is coming from glass or some shiny objects. So IR sensors cannot capture an image through glass, because glass tends to reflect the heat of the object both in front and behind it. So this is one of the biggest disadvantages right now that researchers and engineers are trying to cope with, because if you have a shiny surface, and this is very very common scenario. If suppose a person is crossing a building with glasses, the camera IR sensor won't be able to see it. So if any one of you have question in mind, like we have already talked about the advantages and all the benefits of IR camera. So this is one of the biggest disadvantage of IR camera, and researchers are working on it to rectify it. The resolution of a thermal image. I'll go back to the previous slide. Yeah. So on the bottom, you can see the resolution of the image is not good. And this is not the resolution we get from normal RGB camera. So this is one of the major issues. That's why I said when deciding about a particular IR camera, you have to keep in mind the resolution. Just to cut out the cost, we cannot go with the option of low resolution, because in the end it will affect the results and it will affect the testing of the autonomous vehicle. So resolution of the thermal image is very important to consider while purchasing the camera or selecting the camera. Also, as I've already mentioned, the cost of IR's cameras is quite more than the normal cameras, because in that we are using thermal sensor instead of just light sensor that we use for the normal cameras. It is not as expensive as LiDAR. LiDAR is more expensive than thermal camera, but this discussion, this webinar is not about if we want to go for LiDAR or if we want to go for thermal camera. This discussion is about if we want to go with the thermal camera instead of normal visible camera. Yeah, now we are going towards the end of the webinar, and I'll discuss the possible career path and a demo video for you guys, so you can understand the difference between normal camera and IR camera. You can go as a computer vision engineer or perception engineer or sensor engineer, but for that you need to have a sound knowledge of sensor modeling, and you should have a background in electrical or computer science. It is not necessary to have this background. You can always learn in the industry, but it is always better if you come for this background. You understand these terminologies better than anyone coming from a different background, so you can contribute towards the research in a better way. And once we have these images from thermal camera, the basic question comes in mind is, what do we do from these images? Like, we have captured the images on the road, we have captured all the scenarios. Companies are trying to run millions of miles on simulation, because before we have to move on the road for the fully autonomous systems, there's a certain limitation that of kilometers that a company has to follow, and they have to show it to the government that, okay, we have tested these many kilometers for our vehicle and it is safe to go on the roads. So for that we need training and testing, and typical task of machine learning engineer or a computer vision engineer is to train and test these autonomous systems. And when I say autonomous systems, I talk about object detection algorithms, the localization algorithms on this sensor data. And once we have our model fully trained on this data, then we create a different set, that is test set. If any one of you have any question in how we train or test the data, how do we divide the data set into these three types? Because when we talk about data set, we have training data set, we have testing data set, we have validation data set. So this video will answer most of your questions, why IR camera is better than a normal camera. And please watch it carefully. And if you have any questions, please feel free to ask. Yeah. On the right, we have an image from IR camera. On left, we have an image from normal camera. So this is the question of sun glare, that this scenario of sun glare. This is the scenario of light pollution, the glare coming from incoming vehicle. This is the case of tunnel. So I'll pause the video for now and I'll explain you one scenario. In current testing of autonomous vehicles, what normal camera is facing issue right now is adjustment to the light to the surroundings, to the atmosphere. So one of the problem is when the car enters the tunnel and when it leaves it, the normal camera is not able to adjust its vision when changing the light. In that case, it creates a blind spot. And we do not want to create a blind spot when it comes to autonomous vehicles, because such blind spots lead to accidents. And Researchers and engineers are trying to optimize the position of sensors right now. They are trying to optimize the sensor of LiDAR. They are trying to optimize they are trying to optimize the location of LiDAR. They are trying to optimize the location of camera on the vehicle, and they are trying to use as minimum sensors as possible to cut the cost of the autonomous vehicles, or else nobody wants to have such vehicles if they cost us millions of dollars. It is really important for engineers, for us, to understand how many sensors do we have to use and what should be the position of the sensor on the vehicle to create minimum blind spots for the specific road conditions. I'll play the video again for you guys to see. This is the fog condition. This is the rain condition that one of you has asked about. Again, from the heavy rain, you can clearly see that IR sensor is able to classify the object in an image. Later in the video, this is the critical scenario. On left, you can see there is no object, but on the right, you can see the thermal camera have already detected the image long before the normal camera did. Night scene road. This was the accident case that happened in Uber. So if they had the IR camera at that time, the accident would not have happened. Again, underground parking. This is again one of the basic uh, problems that researchers are dealing with right now, and the concept behind this problem is same: the change in atmosphere, the change in surroundings, the change in the lighting conditions. So camera is not able to adjust to these lighting conditions as fast as they are expected. So in case we should use IR camera. This is one of the cause of accident at night, because of animals, because they are not as sounded like human, and they cross the road anytime and it leads to an accident. This is the range estimation. So range estimation is, I'll show you again. Yeah, range estimation is nothing. It's just calculating the distance from our vehicle to the nearby target object. So it is quite useful in that case as well, because researchers need to know the distance between their own vehicle and you. When you read about this on internet, you might come up with a new term, that is ego vehicle. Ego vehicle is just a headshot for you guys. Ego vehicle is nothing. It's just a vehicle that you are testing on. So ego vehicle is a vehicle we are testing on, and so time span of the decision to know when the operating system of the car should act, should decide what to do. It is really important for us to know the range, the estimation, the distance between object and our ego vehicle. So IR sensors are quite capable of doing that as well. Yeah, this is the example of semantic segmentation. So semantic segmentation is nothing. It's just, as you can see, it is classifying the object classes by a separate color. So all the cars are in the pinkish color. All the buildings and towers and trees are in the golden color. It is not like that in the real world scenario. We classify, we specify a different color for each class. So semantic segmentation is very important, but it is not relevant right now to understand in detail what semantic segmentation is. But in brief, semantic segmentation is nothing. It's just we are classifying we are specifying a separate color for all the classes on the road. Now I'm done with my webinar. Please